Right, 8.3. Thanks for watching. So this is going to be similar to the previous section and kind of following the same pattern as before. Uh, 8.2 talked about the population proportion. We're not talking about proportions here, we're talking about means, okay? I would encourage you to read this section. We're going to do in class some activities based on this section. But to get a whole perspective on what is going on here, I would encourage you to, when you get a moment, to read this section because a lot of important stuff. Uh, there's a lot of new variables that you're seeing here. Okay, so let's cover some of them, and some of them I'm going to be a little vague on because you're going to see them more later and get a further stronger definition. But let's start with S sub x right here, that down there. S sub x is usually the sample standard deviation. Okay, you know what n is. Uh, the mean to the right is the mean of the population, mean of the sample. Uh, you'll see down here we have df. That's called degrees of freedom, as it says right there. That's something I'm not going to overly elaborate on right now. The main thing to worry about with degrees of freedom is that the shape and spread of t distributions depend on the degrees of freedom. And I guess we should talk about t distributions right here, right? That's what you're solving for in this equation right here. Simply put, it says how far the sample mean is from the population mean in standard deviation units. That's basically what it is. We'll be working with this a lot in this section. We have some rules for constructing a confidence interval for this. And they're the same rules. First two rules are same. Third one, though, is that sample size needs to be large and greater than 30. Standard error of the sample mean is simply just sample standard deviation divided by the square root of n. Okay, that's all I have to do to calculate that. One sample t interval for the population mean, where we have the sample mean plus or minus critical value t times sample standard deviation divided by square root of n. Okay, that should look somewhat familiar, and same with the margin of error formula from last time. Okay, just a couple small differences. That's all. And those small differences are mostly just the fact that we're dealing with the mean instead of the proportion. And here are some tips for finding the right sample size for this. Go ahead and jot these down, and then we're going to do some examples based off of what I just went over. Here's our first example. I'm not going to read it out loud, but I'll trust that you pause this video and go ahead and read it. Now I'm going to trust that you can state like, hey, it is fact random. Hey, it meets 10% rule. Hey, sampling more than 30. Okay, so should write it down whenever doing these types of problems. Next, I'm going to write this little formula down as a reminder. Sample mean plus or minus all of this. If you were to put this part in your calculator, so your n is 1,470, sample standard deviation right there. And then you have to calculate this part, just like we did in the previous section. 0.01 divided by 2 is 0.005. Throw that in for your area, and then you will get like 2.57-ish. And then, so your sample mean is, what did it give you here? 240, so 240 plus or minus, it comes out to be 2.83 approximately. So you'll get about an interval of 237.17, comma 242.83. That is what we would interpret. We are 99% confident that the interval from 237.17 to 242.83 captures the true mean of scores of all Atlanta 8th graders. Based on your interval for part A, is there evidence that the mean for all Atlanta 8th graders is less than the basic level? So, what's the basic level? It says in the problem. It's 243. And your whole interval is below 243. So, we can say that there is convincing evidence that all Atlanta 8th graders read below the basic level. Or not, let me rephrase it. Not all Atlanta 8th graders do. The mean for all Atlanta 8th graders. So I should clarify that. Mean for all Atlanta 8th graders. Once again, I'll trust that you read this problem. So since it's 99%, that will come out to be approximately 2.576. We need to find what lowercase n is, right? How large of a sample we'll need. And then your standard deviation, 7.5, less than or equal to 1. Within 1 is what they're asking for, right? So if we solve algebraically, you should get n is greater than or equal to 374. So we need a sample of 374 in order for this to work. We'll be doing more practice with this in class. I appreciate watching, and bye-bye now.